So this video is to show you that you can sometimes use shells and discs, or shells and washers. They both will work for each problem. So if we look at this problem, drawing a horizontal rectangle and a vertical rectangle, they both will work because they both have the same two functions. So if I were to draw this green one at any point in here, they're always the same two functions that are being subtracted. And if I draw the red one in here, they're always the same function. So it's always that y equals square root of x. So we're going to first start, and we'll do this one in red, with shells. So that would become a dy, and that's an x equals. So let's go back up here, and let's solve everything for x so that we have it all perfect. Okay, so if I solve that first one, we get y squared equals x. And there you go, all done. And the other one is x equals 0, right here. Okay, so that one's done, and then we have y equals 2 right there. They're already done. They're ready to go. Those are just values. Okay, so we have x equals y squared, and so that is the function that we have here. This is y squared. So now if I rotate this about the x-axis, that is my cylinder. And so we can see that my radius here is y, and my height is the x equals, so the y squared. So my height will be y squared, my radius will be y, and so that means we have an integral. What is my first y value? Again, we go from 0 to 2. Remember the dy, that is where we keep them, right there. So it would be from 0 to 2. And then we put 2 pi, and then it's RH. So if you remember, our area is 2 pi RH. So then we end up with 2 pi y squared, which is 2 pi y cubed. Move this a little bit. Right there. Okay. So now if we plug that in, y cubed dy, we can then plug it in our calculator and see what the value is. And so it gives us 4. So then it'd be times 2. So that would be 8 pi. All right. So now what I'm going to do is move this rectangle a little bit over so we have a little room for it. And we're going to rotate it now. But this time, it's going to be washers as we rotate it. So again, if it's vertical, that means it's dx, and this is y equals. So we need to go back and look at all the y equals. So we have y equals square root of x, and we have y equals 2. So the big radius here, right, is going to be the 2. So let's draw our washer, and then we'll label it. So the big radius is the 2, and the little radius right down here is our square root of x. And so then if you remember, our formula for that area is pi big R squared minus little r squared. So it's pi, and our big R is equal to 2, and our little r is square root of x. So that would become 2 squared minus square root of x squared, which should become pi 4 minus x. So now if we do our integral, put the pi outside, we're again looking at x values. So since this is dx, we now need to focus on the x's, which would be 0, and then to where they intersect, which is 4. And how do we know that's where they intersect? Well, we just have to set them equal. So square root of x is equal to 2, square, square, x equals 4. So that's where they intersect, right at 4. So we'll go from 0 to 4, 4 minus x dx. And now plugging this to calculator will give us 8 pi. So this should become 8. If it doesn't, we did something wrong. So we're holding our breath, making sure it's correct. And yeah, it's 8. So this also becomes 8 pi. So the whole idea is it doesn't matter if you use shells or washers. The only time you have to use the one that is given, either shells or washers, is when their rectangle doesn't work. So like in that previous video. So this one. So you can see our rectangle would only work horizontal. So the only option here is shells. The vertical will be way, way too complicated. So here both disk and shells works perfectly. All right, so now let's look at Desmos and see that rotation. So as it rotates, creating that solid, and you can see that washer just go through the entire thing. So what our integral is doing is going from 0 to 4. It's adding up all of those washers, creating our solid. All right, let's do it again, but this time now with a different axis. So we're going to rotate this about x equals 1 using both shells and washers, and we'll start with shells. So if we're going to be rotating about this x equals -1, that means, again, to do shells, we have to go vertical. And so I'm going to give it a little bit of space. So to do that, I'm going to draw my shells rectangle right there, and then label it dx and y equals. Give myself a little more room, and rotate it. And then we start labeling. So you can see here that our height is the y equals. So everything needs to be y equals. That's what we have. That's perfect. We have y equals the 4 minus 2x. That's exactly what we want. So we now know the height of our cylinder is 4 minus 2x. We just now need the radius. And so looking at this, this is our x value right here. And right here is 1. So our radius would be x plus 1. Remember, it's that whole subtracting thing again. So we're just subtracting a -1, which makes +1. But again, with shells, it's added to the radius. So now our area would be 2 pi RH. If we plug those in, we now have our area. So focusing on dx, the first rectangle that we would draw starts here. So we start at the beginning of our shaded region, which is 0. And they're labeled up here. It actually tells you what the x equals. X is 0, right? And then that is the rotation. Don't use that one. But the other one is the point of intersection. So if we were to set these two equal to each other, it'll tell us where we intersect. So 4 minus 2x equals 0. Negative 2x equals -4. So x equals 2. So it'll also tell us the same as before where everything goes. So if we plug that in our integral, we go from 0 to 2, 2 pi, x plus 1, 4 minus 2x dx, and that will add up all of our shells. So again, drawing all those shells through here, it will add them all up. So plugging that in our calculator, we get this, which then multiplied by 2 would give us this, which is 40/3. So this would become 40/3 pi. So now let's do it with this. So if we're rotating about that x equals, then we need to do a horizontal to make our washer, in this case, not this. So when I rotate it, I now need my radiuses. But we should always label it. This is now dy and x equals. So that means I need to go back and solve all these equations for x. So y equals 4 minus 2x. Solving this for x would give me y minus 4. Divide by -2. So x is -1/2 y plus 2. So now I know the equation here. This would become -1/2 y plus 2. Now the vertical one is already given. It's y equals 0. So we know that that one would be y equals 0. So when I draw my washer, I know my inner radius, right, would normally be 0, but it's not. So if you look at this, it is the 1. Since we are on the y-axis here, my radius for the inner one is 1. But you can still think about it that way, as that's 0. So what's 0 plus 1? It's 1. So my inner radius is 1. And my outer radius now then would be this little height right here is -1/2 y plus 2. So it would be -1/2 y plus 2 plus 1. Okay, so that means my big R is -1/2 y plus 3, and my little r is 1. Okay, so this would give us pi big R squared minus little r squared for our area of that one disk, that washer. So -1/2 y plus 3 squared minus 1 squared gives me pi, and then I'm not going to multiply that out, -1/2 y plus 3 squared minus 1, big parenthesis, and now we can just plug it in our integral. So we need to know from where to where, and that's our solving just like before. So -1/2 y plus 3 squared minus 1 dy, but we need our start to finish. And we can obviously see that it's the dy, so it's from 0 to 4. But where do we get the 4? Again, we are just setting them equal. So we're going to set this negative 1/2 y plus 2 equal to 0. That's where they intersect. So we're taking our x equals 0 and our x equals negative 1/2 y plus 2, and we're setting them equal. So negative 1/2 y plus 2 equals 0, and then solving that would give me negative y plus 4 equals 0, so you can see y equals 4. Now the other way is just to plug 0 in. We know this is our function, so you could just plug 0 into our y equals function, and it'll tell us it's 4. But no matter what, we're going from 0 to 4. Okay, so now we just have to plug that in our calculator, and we should get 40/3. And so plugging this in our calculator gives us 40/3 pi, which is the exact same answer. So the whole idea is if your fraction works, you can choose either or. You can use shells or washers. It doesn't matter if both rectangles work. Pick the one you like better. So if you prefer washers, use washers. If you prefer shells, use shells. But it all means that that rectangle has to work. And so in our next video, we'll do one where you don't have a choice. Bye-bye.